Hello all. In this video, we are going to learn about the power transmission systems. Power transmission system is so very important while designing a robot. It is to deliver the necessary energy from the source to various parts and components in a robot. These systems provide efficiency, reliable movement, manipulation for the operation of the robot. There are several different types of power transmission systems. The main three are the electrical power transmission system, mechanical power transmission system, and the hydraulic power transmission system, along with the pneumatic power transmission system. First of all, we shall learn the electrical power transmission system. This transfers energy from sources like batteries to components, sensors, and actuators. It enables motion, sensing, and control in the robots. This provides driver actuators and processors. This involves efficient wiring, voltage regulation, safety measures. It is to optimize the power distribution for reliable robot operation. The main important components in electrical power transmission system involves power sources like the batteries, external supplies, or the energy harvesters. This provides electrical energy to the robots. Conductive cables and connectors establish vital electrical connections between power sources and the robot components. The distribution systems route power within the robot. This involves the various different branches for complexity. Voltage regulation maintains component appropriate voltage levels using converters to adapt the power for different requirements. The important applications of robots involves actuation, sensing, control, communication, and auxiliaries. In actuation, motors, servos, and actuators rely on electrical power for movement and control of the robot parts. Sensing involves cameras, LIDAR sensors, and they collect the data and transmit it to the robot's brain. The robots involves central processing units called microcontrollers. They require power to process the data and make decisions. For communication purpose, it involves Wi-Fi, Bluetooth, and other communication methods. Auxiliaries involves lights, displays, audio systems, and also it needs power for integration of the robots. The design consideration of the robot involves efficiency, capacity, reliability, EMI mitigation, and also the safety. Efficiency involves to optimize the power distribution for longer robot operation on a single source. The capacity involves designing the cables and connectors to match the component current needs. Reliability means adding redundancy in the power paths to ensure the operation even during the failure. EMI mitigation means covering up the robot to reduce electromagnetic interference effects. Safety is also an important consideration while designing the robot. The next system is the mechanical power transmission system. Mechanical power transmission transfers energy within the robots, enables the motion and also the operation. This will be having the gears, belts, pulleys, shafts, and couplings forms the basis of the robotic system. This type of power transmission system converts and transmits the motion, force, and torque for precise movement. Importantly, for joint actuation, locomotion, manipulation, and to convey the robots, the mechanical power transmission system is usually used. This power transmission system involves balancing the efficiency, wear, alignment, and the dynamic load handling, which are to be considered importantly. So these are the key important components of the mechanical power transmission systems, namely the gears, belts and pulleys, shafts and couplings, chains and sprockets, and the applications. The gears usually transmit motion and torque between the shafts using toothed wheels of various types. This usually facilitates the speed control, torque application, and the directional changes. Belts and pulleys. Flexible loops transfer motion and power. This converts linear to rotational motion and this links the misaligned components. Shafts and couplings. Rigid rods transmit rotation, while coupling synchronizes motion and it deepens the vibrations in the robotic system. Next type is the chain and the sprockets. This handles heavy torque commonly found in industrial robots. So these are the principles of mechanical power transmission system. The first one is the speed and torque relationship, mechanical advantage, and the next one is the efficiency. The important applications of robots involves joint actuation, wheeled and legged locomotion, manipulation and gripping, conveyors and transport, precision movements. Gears drive robotic joints for precise motion, with gear types balancing torque, speed, and precision. Wheeled and legged locomotion. These types of robots involves belts, chains, and sprockets to transmit the power in drivetrains. These enables wheeled and legged robots to move. Power transmission guidelines, guides, robotic arms, and grippers. This ensures the precise task like picking and assembling. The next important application is conveyors and transports. Gears and belts move materials in industrial settings through conveyors and transport the systems. The next one is the precision movement. Integrate actions like robotic surgery and also the gear systems are important applications in robots nowadays. These are the design considerations and challenges in the robotic system. This involves backslash and play, mechanical wear, alignment and tolerance, weight and size, dynamic load, dynamic load handling, etc. So the next one is the hydraulic power transmission system. This hydraulic system uses pressurized fluids, usually oil, to transmit the power. The main important advantage of this is providing high force capacity, ideal for heavy lifting, and also this can be used in industrial applications. The components of hydraulic transmission involves pump, actuators, valves, and reservoirs. These are the challenges which are to be considered for the hydraulic power transmission system. The hydraulic system can be prone to fluid leaks. This requires proper maintenance. High pressure hydraulic system can generate heat necessitating the cooling mechanism. These systems involve intricate components and requires precise control mechanisms. So the next one is pneumatic power transmission system. These types of systems relies on compressed air for force and motion transfers in robotics. Pneumatic systems use fluid dynamics and it creates and controls and transmits the power. I hope you would have found the video to be useful. See you in the next video. Until then, it's bye from Radhika.